In this video we're going to look at how to use a multimeter. Now the multimeter that we're looking at today is the Appa brand, and it's the Appa P3 true RMS multimeter. We're going to look at its features and what the settings all mean and how to use this instrument. So I'm going to go over some of the features that I do like about this particular instrument. First of all, its price. Its price in New Zealand dollars is around about $150. I like the soft case, and with the soft case we have the magnetic back, which is really useful when you're working on your own and you want to set the meter up on, say, the metal side of a switchboard while you're doing your measurements. It allows you to be hands-free, just working with the probes. Okay, standard leads, probes come with this particular instrument. It's actually a product that's made by the Appa Technology Corporation, and it's made in Taiwan. The quality of the build is excellent. It's very robust. It's designed to take a drop of up to 4 feet onto the ground and survive that. So perfect for tradespeople and technicians alike. So down at the bottom of the instrument here we have our sockets where we connect our leads, and also here we have our category rating of this particular instrument. So it has a Cat 3 voltage rating of 1000 volts and a Cat 4 rating of 600 volts. It also has a maximum 10 amp fused outlet for doing our amperes measurement on AC or DC. So our typical position for our test leads will be common from here, common, and into this socket here for volts, ohms, diode, measurement for capacitance, etc. will all go in these two sockets here. Then when we want to measure current only, so measuring AC or DC amps, common, and over here to the amp socket. So I'm just going to go around the selector switch and we'll look at what all of the functions are. So at the moment it's sitting in the off position. If we move it down here to the auto voltage and low impedance position, that allows us to work on automatically. It will sense AC or DC voltages, and it will work at a on that, and at that value, just on that low impedance position, it's just allows it to operate without picking up any ghost voltages. Then we've got the off position where it is at the moment. Then the next selection is on AC volts. Now we have the option to use the little shift key, if you like, up here, the yellow key or yellow-orange key, which allows us to change the AC volts to the measurement of hertz. And then we move around to the voltage for DC, direct current. And then we move around further to the millivolts DC. And then my next position is ohms for measurements of resistance. And then the option also on that position is we can have the beep off or on when we have continuity. Along with the beep, we also get the little flashing light coming up here. Well, it actually is solid red when we're doing continuity. Then the next position is the measurement of capacitance. And the unit for capacitance, of course, is the farad. So that'll give us microfarads or nanofarads. And then pressing the shift key allows us to do diode measurements for diode testing, semiconductor diode testing. Then after that we've got the amps AC position and frequency. The little blue key there is to have the backlight on or off. And another feature which I do like is the volt. Basically it's a non-contact volt position where we bring the surface of the multimeter in close proximity to a live supply, and it'll beep and flash the LED there. It's a non-contact voltage detection position. As a, if you like, a lower end as far as cost-wise goes for an electrician or a technician or an engineer that's doing measurements for electrotechnology and electrical isolation, etc., I think it's actually a good instrument. It serves your needs, and as I say, it's well priced and it's a robust instrument. I'll just go over a little bit more detail down here, what we actually mean when we talk about the category ratings or the CAT ratings of these instruments. So we have typically CAT 3 and CAT 4 on an instrument of this quality. So our CAT 3 rating is for distribution wiring, and that also is including main feed buses and feeders, branch circuits, etc., with permanently installed loads. Whereas the highest rating is a CAT 4, and this here has a CAT 4 rating of 600 volts, which is when we're doing installation or at the origin or the utility position of voltage measurements. And the problem that we are worried about, if you like, why we have to be concerned about getting an instrument with these values of category rating, is that if we're doing a measurement and we get a transient occurring on the system while we're doing our measurement, it's the ability for the instrument to actually contain that energy and be safe to the user, basically, if that was to occur. So you pay a little bit more, but to do the measurements which require these higher CAT ratings, you really need to have an instrument that is designed to cope and is rated for those particular conditions. It's not unusual to get something like a clamp ammeter that has a category rating of, say, the CAT 3, and even sometimes lower, but I wouldn't personally go below a CAT 3 for an instrument, to be honest. As an electrician, we typically are expecting our instruments to be a CAT 3 and CAT 4 rating. So I'm just going to turn on the instrument and we'll just get a little feel for how the display looks. So I'll just turn the knob on here. Okay, settle down a little bit there. What I like about it also is we have a bar graph that goes around the top of the screen, as well as the digital display for the readings. It's quite a nice feature. Let's go around a bit further, and I'll turn on the backlight as well. Okay, so that's nice, gives us a nice light for the displays. You know, you might be working in a fairly dark area and it allows you to read the display nicely. Battery indicator, not too far off, requiring new batteries. The fact that it's true RMS is a really big deal. And the importance of that is that, you know, it allows us to be able to measure voltages and currents that are not necessarily sinusoidal, not pure AC, not a pure sine wave, if you like. And that's important to actually have a true RMS reading instrument for this reason, so that we can get the accuracy, if you like. So the RMS stands for root mean squared, and just a little bit background on the root mean squared. If we have, say, a 230 volts AC RMS, that has the equivalent heating effect of 230 volts DC. So by having true RMS, it means that we are able to, the actual the actual multimeter does some internal mathematical computations, if you like, to allow for the non-sinusoidal waveforms that occur on some measurements and display the true RMS value of those voltages and currents. So just a little introduction to this particular multimeter. Ideal also for a home user. You know, it allows you to do voltage measurements if you need to. So remember, when we're using this instrument to measure voltages, the probes will go across the supply, so in parallel with the supply to be measured, or across the component that we're measuring the voltage dropped across. When we're measuring currents, of course, measuring the flow of current in milliamps or amps, up to 10 amps maximum, we have to insert this instrument into the circuit. So we break open the circuit and the instrument will then be in circuit measuring current flow. So not as simple as using a clamp-on ammeter, where we just clamp it around one of the conductors to measure the current flow. Here we have to physically open the circuit, insert the test instrument, and then take our ampere measurements. Of course, measuring the resistance in ohms, we must always make sure that the circuit is completely de-energized, isolated. The meter will not be very happy if you have it connected to ohms or set it to ohms and put it across a live supply. That would be pretty devastating. Measuring capacitance, again, the capacitor should be discharged, and we'll be able to measure and compare the accuracy of the capacitor. So it's ideal for, say, motors, single-phase capacitor run motors, to check that the starting capacitors are within spec. Diode measurement allows us to reverse and forward bias diodes, and frequency measurement might be useful as well. Another feature up here which is quite good is that we can measure the peak value, so good for like an inrush voltage or current. And also we've got the hold key, which means we can actually hold that value that's on the screen and then walk away with the instrument, if you like, and then maybe show some other technician what the reading actually was. Anyway, just a short introduction to this particular multimeter. I like it. I think it's a nice instrument. It works well in the field and also on the workbench. I do like the fact that it's got the stand. And of course, as I said, the magnetic backing is very, very useful feature as well. Not all instruments have that, even the higher cost ones, higher price ones. So thank you for viewing this video, and I appreciate all of my subscribers to my small channel, and I hope that this will be of some use to you and give you confidence when selecting a multimeter for your purchase, and also how we actually would drive the multimeter as well. See you later on in another video.